All right, guys. First lesson we're going to talk about relations and functions. So you're looking for that sheet that says relations on the first page. Well, that was the one on this side. Relations on the first square. Okay. Relations and functions. Again, review stuff from Algebra 1, but we're trying to just make sure we got a firm foundation on things. The sets of ordered pairs can be shown in these four different answers here. Can be shown in a table, a mapping, a graph, or expressed as an equation. Those four different ways, and we're going to go through each one of those individually. Table of values, a mapping, which is you've got two bubbles and you draw arrows between them. Graph, which is ordered pairs, you graph them on a coordinate plane. And then an equation, and that's where we're headed for the bigger thing. That's more algebra-like. The set of x values, second bullet point there said set of x values is called the domain, D-O-M-A-I-N, the domain, the x values. So anytime we talk about domain, we're talking about x values. Anytime we're talking about y values, we're talking about the range. Okay? The relation with with distinct points is called the discrete. All right? Discrete. And then the relation with connected lines or curves is called continuous. And that's always kind of a slippery thing there that is hard to discern. My stats class, we talked about this in the beginning of the statistics course about discrete and continuous. Discrete is like counting how many people are in the room. I can count, there are 2, 4, 6, 8 of us in the room. There's not 8.5 people. There's not 8.65 people. There's a distinct number of things. So when you think about discrete, you're talking about separated values. Continuous, you're talking about maybe if you were measuring how tall everyone was, that you can measure very precisely that I am, 5 feet, 9 inches and 3/4, or something like that. And then the next person might be 5 foot 9 inches and 2/5, something like that. So the continuous is there's no gaps. Discrete, there are gaps. When we talk about relations, a discrete relation is individual points. A continuous relation is going to be a straight line. Okay, so discrete, individual points. Continuous, it's going to be a line connecting all that stuff. Okay. All right. Next box talks about functions. A relation in which each element of the domain is paired with exactly one element of the range is a function. Okay. An example of a function, I'm going to write it as a set, curly braces, and then ordered pairs. 0, 1, -5, 2 is the second ordered pair. 6, -2 is the third ordered pair. And let's just do one more. 5, 7. That is a function because domain is paired with one element from the range. So each element of x, all the x values, are only paired with one y value. The x's don't repeat. That's the thing you want to write there. To be a function, x's don't repeat. X's do not repeat. Okay? Be a function. Not a function. Example of that would be a set. Do -7, 2, 6, 7, 6, 2, -3, 9. Because the 6's here repeat, those are x values, they repeated, it's not a function. So functions, x's do not repeat. That's the rule to be a function, is the x's don't repeat. It's okay for y's to repeat, but you cannot repeat x values. Okay. The other test for whether something is a function is when you have a graph. If you've got a graph of an equation or some sort of thing they want to test it as a function, you can use the vertical line test. And the way the vertical line test works is you might have a graph. I'm going to draw that, just a line like that. Just a slanted line, doesn't have to match mine perfectly, but it's a straight line going up and to the right. That passes the vertical line test because no matter where I place a vertical line on that picture, it only touches that one time. Okay? And that's what this over here on the left says. In order to be a function, a vertical line cannot pass through more than one point on a relation. An example of something that's not a function might be like a circle. Try to draw a decent circle. Decent. Okay, so we have a circle there. If I drop a vertical line on that one, that dotted vertical line there, it touches that circle in two different places. So that fails the vertical line test. So that picture is not a function. Vertical line test decides if something is a function or not. Okay? Let's do a few examples here. They want us, the directions for these examples down here at the bottom are to find the domain and range of each relation, then determine if the relation is a function. Okay? So domain are what values? X's. So we're going to list the domain. So for number one, what are the X values? And I generally put them in order, least to greatest. That is not a requirement, but is how you will most often see the answers. Okay? The range, what's range relate to? Y's. So we put the Y values. So we got -9, -5, -2, and 3. Is that a function? Yes. Yes. No X's. X's do not repeat, so yes, it is a function. So say yes. Yeah. Number two. We'll do it real quick. We won't do every example on the page, but we'll do some. So, what's the domain of that one? Since that 5 repeats, we're only going to list it once. So anytime you have a repeated value, only list it one time in your domain or range. Okay? So don't list it twice when you're listing domain and range. It's listed twice in the ordered pairs, and that's okay. But when you write your domain and range, only list it one time. Okay? The range for that set would be -6, 0, 2, and 4. Is this a function? Why not? The X value of 5 is repeated, so it's not a function. Okay? So from a set of data, we've got a relation that's ordered pairs. We can decide if that's a function or not based on repeated X values. Looking at number 3, this one really laid out for you. You got all the X values here, all the Y values here. These are ordered pairs. Is that a function or not? Yes. Are there any repeated X values on the left side? No. So it is a function. Where would the domain be? All the left side there. Okay, so I would write out -4, 0, 2, 7. They wrote it, they had it opposite order there. The range and 3. Is it okay that it repeats a Y value? Yes. Not okay if it repeats X values. Number 4 is almost the same problem. We're not going to do it. Okay, no sense in redoing the world there. All right, number 5 on the next page. These number 5 and 6 are what we call mappings. Okay, the left side bubble, the X's, that's all your domain values. The right side bubble is your range. The arrows are what creates the ordered pairs. So it's the same thing as the list of ordered pairs and as the table, but it's arrows that make those ordered pairs. So from -4 to 0, that's an ordered pair, -4, 0. -2 to 3, that's an ordered pair. When we get down to the 5, how many ordered pairs does that 5 make? Very good. It's not a function because that 5 creates 2 ordered pairs. Our domain, these are even easier because they don't have any repeated parts. 0, 3, 7, 9. Okay. When you get to number 6, they try to confuse you by making all the arrows cross, but all you got to do is follow the line. It's not anything. But what is 7? Is it a domain or a range? It's part of the range, so it doesn't matter. It's repeated. Okay, so, yeah, 6 would be a function, and you could list the domain and range for that. All right, 7. Is that a discrete or a continuous graph? Discrete. Why? Because they're not connected. They're not connected. They're separate points. That's what we mean by discrete. Is it's separated. Okay. Could you connect it? You don't need to. Don't need to connect it. What we do need to try though is the vertical line test, because it is a graph. We can still check that with the vertical line test. So if I lay a vertical line on that graph, if I choose to lay it through this point, how many points on the graph did it touch? Just the one, okay? But what if I put that vertical line right here? How many does it hit? 2. So that is not a function. All right, this is a little bit more difficult to get the domain and range for. The domain, what are the x values that are represented by these ordered pairs? 1, 2, I got -3. Be careful on your counting there. And then this one would be 0, 2, and 1, 2, 3, 4. Now the y values. Okay, so we've got 1, here's -2, there's -1, 2, 3, 4, 5. -5 is here. I'm going to list -5, -2, -1, 1, and 4 for the range, or those y values. Okay. We get the domain and range. It's not a function that we can still get domain and range from something that's not a function. Number 8, is that a discrete or a continuous graph? Continuous. It's a line that's connecting all of these infinite number of ordered pairs there. Okay. Does it pass vertical line test? Absolutely. It's just almost exactly like the example that we had earlier. Okay, so this is a function. Here's the even harder part. Domain and range. Because it is continuous, we can't list out individual x values for the domain. We can't list out individual y values for the range. We never could get them all because that line is continuous. Because if you wrote +1, 1.5, 2, well, there's still a whole bunch between 1 and 1.5 and between 1.5 and 2. You could never get them all. So we've got to use that interval notation that we talked about in the first unit that we were doing to get our domain and range with these. Okay? So we have to watch which direction the graph is going. All right? What direction, left or right, since we're dealing with domain first, left or right, how far does it go to the left? I'm counting from the arrow on the end. Think about our inequalities that we graphed. When there was an arrow on the end, that meant it kept going that direction. This one is kind of pointing down, but it's still going to the left some. So that would be negative infinity. And then to the right, it's pointing up and to the right, but it's still going to the right. So that's going to head toward positive infinity. So our domain for this one is negative infinity, positive infinity. Yeah, parentheses on both because you never can get there. So never a bracket on the infinities. Okay. The range, when you look at a graph and you try to read the range, you want to read bottom to top. Domain, you want to read left to right. But range, you want to read bottom to top. Okay? So when I read this bottom to top, where is this arrow pointing toward? It's going down, isn't it? And that would be in the y direction going toward negative infinity. This arrow is going up. And in the y direction, if we continue to go up, we're going toward positive infinity. So the domain and the range for this one are both all real numbers or negative infinity to positive infinity. Remember that also means all real numbers. So don't forget that using those words means the same thing. I like the interval notation best, but know that also means that. All right, let's look at another one. These graphs are the hardest ones in this section, so I want to spend a little bit more time on those. Okay? Looking at this graph, does it pass the vertical line test? No. No, it fails that. So this is not a function. Easy to tell that. Now, domain and range, that's the hard part. That's the part we're going to struggle with a bit. Looking at the arrows, reading it left to right, is there a first x value that we come in contact with that isn't negative or a negative infinity? Because it doesn't look like the arrows are pointing toward the left at all. -4. -4. That first x value there is -4. Right here is where I'm talking about, that point right there. So the domain starts at -4, and then those arrows point where? To the right. It doesn't matter about it going down. When we're talking about domain, we're just talking about left to right movement. So we're starting at -4, and we're going toward positive infinity. Now, why? To the -4? Yes, because that is a point on the graph, so we're going to use a bracket for the -4. What about range? Remember, we're going to read bottom to top. Negative infinity to infinity. That little corner there, yeah, there's kind of a weird looking place there, but it doesn't affect range because range, it never stopped. It got to that corner and then turned and went up. So it's okay. Yeah, here we're going from negative infinity going up toward positive infinity. So that would be our range for that one. Okay. What would be the inequality version of this? That's something that we got to be careful with sometimes. That interval notation could also be written in inequality notation. This would be x is greater than or equal to -4. That would be saying the same thing. Okay. So being able to bounce back and forth between inequalities and interval notation, that's a large part of Algebra 2. And if you can get it now, you don't even have to worry about learning it in college algebra because it's the same thing. Okay, but they both have that skill we got to learn. All right, let's look at number 10. Is that a function? No, we did an example almost exactly like that. But is it discrete or continuous? Continuous because it's a nice circle with line, not individual dots. What is the domain? To 5. Brackets or parentheses? Brackets, yes, because those are x values. And what's the range? -2 to 4. Yeah, -2 to 4, and brackets on those. Inequality notation for the domain. -2 less than or equal to x less than or equal to 5. On the range, it'd be -2 less than or equal to y less than or equal to 4. Those mean the same things as that interval notation. All right. Questions about up to number 10 so far? All right. Number 11 and 12 and 13 and 14, we're going to talk about graphing with the calculator and general knowledge about graphs. The first one is y equals negative x squared plus 3. You graphed problems like this in Algebra 1. And if you took year-long Algebra 1, it was in the spring semester, probably somewhere around March that you started doing that. If you had me for Algebra 1, that's when we did that. Now, what we want to do, I'm going to show you how to graph that with the graphing calculator. So if you've got a graphing calculator, I'm going to set mine to normal window. I'm going to clear out some stuff that I'd graphed for college algebra. So to graph with the graphing calculator, you've just turned it on. I've cleared out my regular calculator screen, and I want to graph an equation. So I'm going to hit the y equals button, which is in the top left corner. And then I'm going to type in the equation I want to graph. I want to graph negative x squared plus 3. So I'm going to hit a negative sign, just down here by the decimal point. The x is the button right beside the green button. That's where you get your x. Hit that button. And then to square that, they have a button for squaring. It's right here, kind of diagonal up from the 7. We hit the x squared. And then plus 3. So I hit the plus sign and 3. I know from Algebra 1 that this should make a parabola shape. So it's a kind of that curved shape that does like that. This one will be pointing down just like my hands are doing right here because it's got a negative in the front. I know that stuff from Algebra 1, but my graphing calculator can draw the picture for me so that I don't have to go through all the steps that we taught you to do in Algebra 1 to graph it by hand. Because all we want to know is this thing a function. So I'm going to hit graph, and it draws the picture for me. Yes. So much faster than doing it by hand. Okay? Now, if your picture doesn't look like mine, you may need to hit zoom 6, and that will reset your window to 10 by 10 like mine is. If yours looks like mine, then you're good. Yours didn't grab it? Okay, let's see what's going on. There's, yeah, see that. Let's see if you can see the resets. Opens. Get rid of it. I'm just airing down to it, clear it, delete it. There's 4. All right. Now, go there. Good. Yes. Anybody else? Okay. So, does that pass the vertical line test? Yes. Yes. So it is a function. What's the domain of that function? This is a yes. The domain, when you look at that graph, it continues to the left. This graph keeps going kind of down in this way. It doesn't stop. Okay? So that's going to be from negative infinity to positive infinity. The range, however, starts at negative infinity, but where does it stop? Now look at that graph. Where's the top of that graph? 3. So that's where my range is going to quit, is at 3 bracket. So nice little graph with the graphing calculator to get that to happen. If you don't have a graphing calculator, you can graph that equation using the tools you learned in Algebra 1, which would be plug in x values, get a few dots, and find out what kind of pattern it's making. Start at like -5, go all the way to +5 with your x values, plug them in for x, work it out, and get the y value that goes with it, and you'll end up getting a picture that's dots that show you that parabola shape out of that. Number 12, we got another y equals equation there. What do we know about that graph before we do it with the calculator? Y equals negative 5x minus 1. Remember what kind of equation that is?
What is the calculator?
15. You get it for the whole semester. 15. Blank intercept formula. Slope intercept formula. Okay? Y equals mx plus b. So we know from Algebra 1 and 8th grade math that is a y-intercept of -1 and a slope of -5. So it's going to go down and to the right, but it's going to be a straight line. Just from remembering what we did with those equations back then. The good news is I got a graphing calculator, and I'm going to graph that. I'm going to go to y equals. I'm finished with this equation, so I'm going to clear it out. I'm just going to hit clear, and it'll delete whatever's in there. Okay? And then type in negative 5x, so the negative sign of 5, the x, and then minus 1. It is important to realize with the TI 84s, 83s, whatever you're using, the negative sign and the minus sign are not the same thing. The negative sign is down here close to the decimal. The minus sign is up here. It does not recognize each as different as the same thing. Okay. If you put the minus sign in front of 5, thinking that means -5, it's going to throw it back at you and say, you can't do it that way. It's a syntax error is what it'll give you. I'm going to hit graph. There's that nice line that we knew it should have been, just based on general knowledge about equations of lines. Okay? So, function, yes, we know lines like that are functions. The domain would be -infinity to positive infinity. The range would be the same thing. It's just almost exactly like number 8, the example that we did with number 8. 13 and 14. This is almost a memorized fact. I can graph y equals -7 with my calculator. If I hit y equals and then clear this out and just type in -7, y equals a number is a horizontal line. Does a horizontal line pass a vertical line too?
Yes.
Absolutely. Okay. So that one is a yes on the function. What would the domain? Yes, -infinity to positive infinity. All right, look at the graph. It continues to the left forever. It continues to the right forever. So that's why our domains can go both directions. But what about range? Doesn't go up or down. It only stays at what y value? What's this y value? What is it from the equation? -7. So the range is just going to be -7. I'm going to put brackets around it. That's the only y value that exists for that problem. No other y values. Now, here's where a limitation of the graphing calculator comes in. It can't graph x equals a number without the help of some sort of app or program. So, but all we got to remember is, hey, if y equals a number is horizontal, x equals a number is going to be what? Vertical. Does a vertical line pass the vertical line test? No. Absolutely not. So it is not a function. Put no there. The domain, what's the only x value in that problem? -1. And then the range, yes. So those are not too terrible. Okay. The graphing calculator can help when it's an equation that you don't know much about. Most of the ones you're going to see in this particular homework set and practice is they're going to be equations that you can either make the graph for pretty easily by plugging in x values, or you know a slope-intercept formula equation. You know what it looks like. That idea. Okay, so don't freak out. But I think some of you may be seeing the beauty of the graphing calculator and how nice it is sometimes for this stuff. Okay? All right. Let's get into